Welcome to Owie and Sandy Math Along. I'm Sandy.
And I'm Owie.
Number 6. Given this figure, what is AF? AF is this little line right here. We want to find a value for it. They give us a couple values on this figure. They tell us our height is 40. Our length between F and E is 80. Okay, we have the 60-degree triangle over here, or angle over here, I should say. And we have a 90-degree angle, which means it's a right triangle. And our height is going to be 40 over here as well. So we want to focus on the angle we were given, which was 60. So we're going to do some kind of trig function to 60. We have what is opposite. Okay, I'm going to put opposite. And we want to find what is here, which is the adjacent. Okay, it's touching that angle. I'm going to put an A for adjacent. You don't have to use A. You can use any letter. You could use X if you want. And now, since I have opposite over adjacent, that is tangent. Tan is opposite over adjacent, and I want to solve for A. So cross multiplying would probably be our best bet here. I have A tan of 60 is equal to 1 times 40, which is just 40. And to get A by itself, I divide both sides by the tangent of 60. That makes this one cancel out. A is equal to 40 over tan 60. That would be my answer. Now yours looks a little different as always, so it'll be a little bit different. Number 7, given the right triangle, which of the answer choices is equivalent to tan theta times sine theta? Now yours is different. Yours is tangent of theta times cosine of theta. I'm using sine because I like to mix it up. So we are going to look up here. Remember, theta is just a Greek letter. Okay, you can think of it as an X if you need to. That's fine. Tan theta. Now, tangent is opposite over adjacent. Remember, SohCahToa, where toa's tangent opposite over adjacent. So to find our opposite, I'm going to go across the triangle. That gives us a Y. Adjacent, let's look at the two legs that make up the angle. One is always the hypotenuse across from 90, and one is going to be the adjacent, which is Z. Okay, that's the one that it's touching. Sine theta. Okay, so let's go to our opposite over hypotenuse. There's that 90-degree angle pointing straight at our hypotenuse, which is X. We're not done. It wants to know what's tangent theta times sine theta. Well, Y over Z is tangent theta. I'm going to change colors for fun just because I have extra markers. Okay, so tan theta is Y over Z times Y over X, which is sine theta. Y times Y is Y squared. Z times X is ZX. You could also say it's XZ. The order does not matter in multiplication. So Y squared over ZX is my answer. I would go through the answer choices and see which one matches up. Yours will be a little different, so you have to look through and see which one matches up to yours. Number 8, bonus question. we are given a triangle and asked what of the answer choices is a proper setup for one of our inverse functions. Okay, I saved some time and wrote out our inverse functions down here already. But remember, and then I already found a mistake. E. Okay. Remember SohCahToa, and we have our cosecant, secant, cotangent. We talked in class a little about how to remember what goes with what. Cotangent goes with tangent, okay? And what happens is these flip, and then I put my C and S's go with each other. Cotangent flips this to HO, hypotenuse opposite, and CH, the secant, flips that to HA. Okay, so those are our three different inverses. I don't know how, what SohCahToa, SohCahToa, I don't know either. I do not have a mnemonic device for that. So if you can think of a way to remember it, you do you. Okay, now on this triangle, they're looking at both the F and the E. Yours is different. Yours is not triangle DEF, and your answers, your legs are not ABC. Mine are. So first I'm going to go through, just like I did in class, I'm just going to find all of them instead of trying to pick one out of the answer choices. So I'm going to start with cosecant, and I'm going to do F for all three. Cosecant, this one, is the opposite of so we're going to do hypotenuse first. Remember, that's our arrow pointing to the hypotenuse. Over opposite. Opposite of F is B. Secant, opposite of cosine. We're going to do hypotenuse adjacent. So we have our hypotenuse, and our adjacent makes up this angle we are looking at, the hypotenuse and the adjacent, which is our A. Cotangent, opposite of tangent. We're going to do opposite, adjacent. So we already found opposite is B, adjacent is A. Okay. Over here, we're going to do our angle E. If you look at your answer choices, they give you answer choices for both F and for E. So now we're going to run this one through. I'm going to erase my arrows because I'm going to switch over to the color red now for E. Just a personal preference. Now our hypotenuse stays the same anyway. It's going to be C. But now our opposite comes over this way. Our adjacent is now B. We touch the hypotenuse and B. Okay? So cosecant, hypotenuse opposite, hypotenuse opposite. Secant, HA, hypotenuse adjacent. Cotangent, switch up that tangent, that TOA. We have AO, adjacent opposite. My adjacent is B, and my opposite is A. Okay. At this point, we can look at the answer choices and see which one matches up with our answers. Of course, you have different letters, so pay close attention to what order they're putting them in. And notice they are all inverse functions. They are not the regular functions that we've been dealing with. Number 9, you have an observation deck that's extended out from a set of mountains or a row of mountains. On your problem, they tell you how long this mountain is. On mine, I listed how far it is from the edge of the mountain range to the observation deck. Either way, you have a right triangle. We also have these little degrees down here are 25 degrees each, or 50 total. We want to know how far is it from the mountains to the observation if you go from the center of the mountains down. So you and I are both finding the same length, but we have different triangles because I set mine up differently. So you're going to use a different trig function than the one I'm using. So I am looking from this 25-degree angle. We're going to have to figure out what trig function to use. I want this length, okay, which is my adjacent, okay? This is my adjacent. I'm going to call it A because, adjacent. And then we also have 25 feet. Well, it's directly across from our 90-degree angle. So this is our hypotenuse. I'm going to write that out, okay? So if I'm dealing with the adjacent and the hypotenuse, I am using cosine. Cosine of 25 is equal to the adjacent over the hypotenuse. You are going to use a different trig function because you are given this up here and you're looking for this one that I'm also looking for. Okay. Now that's not our answer. We can't find our answer until we solve for A. And I just realized I made that 25, which is the same number, but those are two different numbers. This is degrees and this is feet. So don't let that get you confused. We can cross multiply to find what A is. If cosine 25 isn't over anything, we assume it's a 1. So 25 feet times the cosine of 25 degrees is equal to 1 times A, which is just A. That's my answer. That's it. So they are 25 times the cosine of 25 degrees feet away from the mountains. Number 10 is another bonus question. Cosine theta divided by cotangent theta, and you have to pick the answer choice that simplifies this. So what we're going to start with is the definitions of these terms. And since we're just kind of learning them, I'm actually going to write out all 6 of the trig functions we are working with. So sine theta is defined as the SO in SohCahToa. I wrote that horribly. OH. Okay, so that's opposite over hypotenuse. Cosine is the K, A over H. And tangent is the TOA, opposite over adjacent. Let's write their inverses. The inverse of sine is cosecant. You just flip sine. It's H over O. Cosine's inverse is secant. You just flip cosine. We got H over A. And then on tangent, the inverse is cotangent. And I should have been putting thetas in there just because our problem deals with theta. We flip tangent, we get adjacent over opposite. Now, the two that we are working with on this problem, cosine, right here, and cotangent, right here. We want to divide cosine by cotangent. Well, cosine is A over H. That's just its definition. It's adjacent over hypotenuse. Divided by cotangent, A over O. It's adjacent over opposite. We don't have a specific triangle. We're just talking generally. Any right triangle, this is true. So remember, back in middle school, maybe your freshman year, you learned how to divide a fraction by a fraction. And there's a rule that says, or a trick that says, keep, flip, multiply. So we are going to keep, flip, multiply A over H over A over O. Keep A over H, flip A over O, multiply them together. When you multiply straight across. We have AO over HA. Well, they both have an A in common. So these two A's, A divided by A, cancel each other out. We are left with O over H. Now that's not going to be one of the answer choices, but what is O over H? Let's go back up to the definitions we wrote. O over H is sine. So we can replace this O over H with its actual definition, which is the sine of theta. And that would be our answer. Of course, as always, mine's different. I picked different trig functions to divide. You are going to have other ones, but you can still start your process the same way. Write these all out just like I did it, and then highlight the ones it wants you to divide, keep, flip, multiply, cancel out anything that's on top and bottom, and then match up what's left with one of your other trig functions to get the answer. Number 11, we have a transformer running a power line up to the top of an antenna on a house. We are given the angle from the roof up of 35 degrees. Okay, that is from your horizon line, so to speak, up to the antenna. We have a 30-degree angle where the roof meets the top of the house. And we have a 25-foot distance here, which would be from the start of the house over to where that cord comes up and touches. Okay, our antenna. We have a little OE in the window waving high. They want to know, what is the length of the cord right here? So this is one of those real life problems where you could potentially be asked, or not asked, but potentially be out installing something like this, and you need to know how much cord you need to reach that roof from the transformer that you're building or connecting from. So first of all, notice there's a 1 foot difference here where that antenna sticks up. In order to find this, we're going to need to figure out a couple things. We're going to need to know maybe the adjacent side, maybe the height, from the top of the roof up. One thing I notice is this 25 feet can also be used here for this length. That's also 25 feet. And I notice I have a little triangle here. There's a 90-degree angle in the corner, and that's 30. Now, yours is different. I could use the rule of 30, 60, 90 on mine, but that wouldn't be fair to you because you guys don't have that luxury. But I could figure out what this is over here. If I could find that length and add it to 1, that would give me the length of this overall triangle, the height here. So I'm going to start there. So we are working with our 30-degree angle. We're going to have to use some kind of trig function. We currently have the adjacent, okay? And we're looking for its opposite. So opposite, adjacent, that would be not so, not ka, but our TOA, okay? So tangent, 30 degrees, is equal to opposite over adjacent, okay? And I'll put an O here. I just don't want to confuse it with a 0, so I'll write it fancy. Okay, so how do we solve for that? Well, our adjacent is 25. So if I cross multiply, this is over 1. Okay, if there's nothing else there, I have 25 times the tangent of 30 degrees. Let me make this O fancy again, because again, it's not a 0. It just stands for opposite. Okay, equals our opposite. So we have our height. It might not look like we have our height. There's a tangent in the middle of that. If we put it in a calculator, it would give us a number. That would be our height. So we consider this to be our number. Okay, that is our height. Now, the reason I did that, and I'm kind of figuring it out as I go here, along with you, is this whole height from up here to down here is going to be this plus 1 foot. So 25 tangent, 30 degrees plus 1. And I know that's a lot. It's a mouthful. Is this length right here. So in looking at this bigger triangle now, we have a 35-degree angle over in the corner. I'm going to erase that for a second. I should have just written it up there instead, but we're working with our 35-degree angle. Right now, we know our opposite, and we're looking for not the adjacent, but our hypotenuse. Okay, follow that across. That is our hypotenuse. So I'll call it H for hypotenuse. Okay, so we have opposite and hypotenuse. Which one's opposite and hypotenuse? The SO in SohCahToa. Sine is opposite over hypotenuse. So our sine of 35 is equal to our opposite, which was that mouthful, right? 25 tangent 30 degrees plus 1 foot divided by, I'm just going to move that H over, divided by our hypotenuse we're looking for. So to solve for H, we're going to cross multiply. That's over 1 if it's not specified otherwise. And I have my hypotenuse times sine of 35 is equal to 1 times that whole mess, which is just that whole mess. And you're going to leave it intact just the way it is. You do not need to put it into a calculator for this problem. To get H by itself, to find our actual hypotenuse, we are going to divide both sides by the sine of 35. Which means my hypotenuse is equal to this whole big thing here. Now that may look like a mess, and you're kind of right. If we were in a trigonometry or pre-calc class, we would go through how to put that into actual feet. For your purposes, for the test that you're going to be taking, they actually don't make you put those in a calculator, so we leave it just like that. So you're going to look for your answer choice that looks like that.